Wind is primarily considered along the walkway of the bridge and can cause drag forces or a lateral load as well as uplift along the deck due to suction and torsion due to an uneven loading of uplift along the deck. And then these lateral drag forces transfer to the bridge abutment through the towers. So if we look at this in plan, in a elevation or section view, we see those cables coming across the towers, and that lateral drag force can transfer into the tower at the tower saddle due to friction. Now, in order to analyze these forces, we need to actually establish what our wind loading is. So first, I want to point you to the Helvetas manual, which gives a 0.5 kilonewton per meter wind drag loading value. Now, this is based on 160 kilometer per hour winds, horizontal to the walkway, and is equivalent to 1.3 kilonewton per meter squared of pressure, acting on an equivalent area of 0.3 square meters of solid area per 1 square meter of actual fence or walkway area in section. This is the wind loading we will use for suspended bridges under 120 meters. So use a different color here. That needs special wind considerations. And generally, under 120 meter bridges, we won't even consider wind to be a governing load in any direction. Now, in the following units, we will dive into this value further and use various methodologies to come up with a design wind load value. And note that this is the design value, so whether you're using the ASD method or an LRFD load combination method, we will start with that design value, and it either gets factored in the LRFD load or it is divided by a factor of safety or increased by a factor of safety if it's the design value in an ASD method.